get started. I only have a couple of slides just to show what's going on here and who I am, sort of, and everything else will be a demo. There is no preparation, so expect some items to fail or some examples to fail, but let's just have fun. And all right, so this is an Oracle hacking session. My name is Tanel Poder, that's what I say in foreign countries. So this is my email address. You can ask follow-up questions from there. And also something cool what I want to show you is this. This is my pet project. It's called Voicey. So basically, it's an iPad and iPhone app, which allows you to talk to each other asynchronously, right? So you just send a message and fire and forget. And the other guy listens whenever they want and replies whenever they want. So you don't have to pick up the phone or wait until the other dude or girl picks up the phone and then replies. So it's a free app. If you have an iPad or iPhone, try it out. And what I wanted to show is that we have things called channels here as well. Basically, I created a channel called Oaktable World, and when you install the app and add this channel, like so this is an example from the simulator, right? So I go to add channel and type in Tanel/Oaktable World, right? Now you can record a message. You can actually ask questions via voice as well. Busy conferences, it can be helpful. So it records a message, and when you tap it again, it will send it, and I will get it into my pocket. And whatever I answer, it will show up in this web UI as well. So if you don't have an iPhone or iPad, you can still listen to the answers. All right, so Voicey, check it out. All right, so I'm Tanel, so I'm a long-time Oracle internals geek. And I'm not independent anymore. I'm actually working with that maniac there, so Kerry Osborne, and I'm running Enkitec in Europe. So, and we are having a lot of Exadata hacking fun in Enkitec, and this is who we are. And also a few things. So in this URL, you see what we are doing at OpenWorld. So we have a bunch of OpenWorld sessions, but more importantly, today at 3:30 to 5, I'm going to be in Chilean's restaurant, actually even before that, and there is free beer there. Right, we have free beer, right, and maybe other stuff as well. Anyway, so if you like Enkitec and or Europe, then just come over. Or beer, if you like beer, then just come over. So, and Tuesday, so here I'm just going to hack Oracle, traditional Oracle, like I've done for fun for a long time, and tomorrow at 3:30 to 5, again in the Chilean's restaurant, I'm running an Exadata version of that. So it's a secret Exadata session. So in other words, in short, it's a Sexadata session. So Exadata is very sexy in the IT world, right? So everybody wants it. Okay, and on Wednesday we have an Exadata roundtable as well. It's Kerry, me, Andy Colvin, and Tim Fox, who all have done a lot of Exadata work. Well, and that's it. So, and this is the last slide about the agenda, and then we switch to SQL+. So, well, this is what we're going to do, right? So, let's hack the heck out of something, right? So, and it's intentionally completely useless, undocumented, and probably unstable features, which you should not use, right? So, but anyway, so therefore, this is extremely interesting stuff, right? So, let's just look into some internals. And this is it. Okay. And it's completely disorganized and very random. I'm going to start from on Solaris platform, and the platform doesn't really matter, but this is 10G, 10.2. And let's look into some Oracle processes. All right. I have highlighted. So, okay, let's actually start from this. So I'm using a terminal called Terminator, right? It's not the same Terminator what you have with Linux distribution. It's a different Terminator terminal. But if I hit Control F or Command F, then whatever I type in here will be highlighted, right? I can use regular expressions as well. Like if I want to highlight DISM and CKPT or something like that, it will highlight that. Or if I had star in the end, dot star, well, it highlights, it's a regular expression. So anyway, I just wanted to show you this. Okay, so if I run this, I see there are a bunch of background processes, right? And there is a process called DISM. All right. So now I'm gonna query. Let's query this one. So you see, there is a view called $BG process. Okay, $background process. All right, and when I list it, I don't see DISM here. All right. So in the OS level, there is some background process called DISM, but it does not exist in this $V view. So it's like it's there physically. It's there because the OS doesn't lie, right? But it hasn't attached to the SGA probably, and it's not. Doesn't seem to be a real background process. And once I started looking into this, then I realized that Oracle lies to us. So DISM is a phony background process. It's just like there are plenty of examples from nature where there are these big scary animals, and then there is this small one who wouldn't survive unless it pretended that it also was that big scary animal or poisonous thing. So so DISM is actually a phony background process. So when and you see what's going on, it's running as root. Yeah, security-minded people will start thinking, okay, if I run this now and so on, maybe I can get to root from Oracle, right? So it's possible. So anyway, so it's running as root as well. So that's even weirder, right? So we have to actually, let's use PS minus EO. O allows me to select whatever PS columns I want. And I will say, show me the user, show me the P of the process, show me the comment. Okay, I just grabbed Dora as well. All right, so now I see the same output. Comment. This is not the same thing as the actual binary. When a binary starts up, it can issue a system call or something which says that, hey, change my name to this. So when I list fname, this PS command shows me the actual binary name that's running. And you see, there is a binary called Oracle, and this particular process, when it started up, it renamed itself to something else, like this. Because there is no such, when you see the blue highlight, right, there is no such binary, right? There's only one binary called Oracle. And processes rename themselves, or the comment to this, whatever background process they're supposed to be. And you see, the DISM process is actually a different binary, but it just renames it to, so it would be like a background process. So DISM is a completely different process, completely different binary. And let's look into what is it then. So Oracle Home. I actually have a shortcut, Oracle Home bin. You see, this is the regular Oracle process, but this is the DISM, and you see it's owned by root, and you see it has a set UID bit. So whoever can execute this binary, they will run this binary, but this binary will run as root. Okay. So why does Oracle need this? So when you start up Oracle, especially in the old days when there was no grid infrastructure and so on, when you start up Oracle as Oracle, right? And now Oracle wants to put itself into a higher priority class, perhaps, or it wants to allocate, intimate shared memory on Solaris, or on Linux as well. Actually, it used to be an issue where, if you want to allocate memory which is locked to RAM, you have 4 gigs of RAM, and you want to say that I want to take half of that 2 gigs to me and lock it so nobody else would be able to page it out, right? So these things tend to require root privileges. right? So I think in Linux, in recent versions, if you configure the security limits.conf, then it actually, regular users can lock memory as well. But this is the reason why we need a root process. So basically, and why it's called a DISM, it was introduced for Solaris initially. That on Solaris, if you wanted to allocate intimate shared memory, then you had to have the root privileges for allocating this locked memory, right? And that's why it's Oracle process for enabling the use of DISM. So this process has to have the set UID bit. And when the bit got lost because somebody tarred up the files and untarred them somewhere else, right? Then this feature didn't work anymore. I mean, then you didn't have the root privs, and your intimate shared memory was not used actually. And nowadays, on where else is it used? It's starting from 11G, right? There is a parameter called high priority processes. And you can add log writer here if you like it, if you actually would need that and so on. So again, high priority processes will put whatever processes are listed here into the real-time class, right? But if you're a regular user, you cannot up your privileges into real-time. This is what you need root for, right? So on Linux, Aura DISM is also used, even though you don't have the intimate shared memory there. So I can go to Linux. I have a PS, I have a recent PS command here somewhere. Okay. Again, the regular PS minus EF doesn't really show all the columns what I want. I just pick the columns I want, and you see when I look into VKTM, all the other processes are in the regular time sharing class, right? But the VKTM is in the round robin real-time class, right? And you see the privileges are 41 instead of 20 something. So again, how do you put the process into real-time class when you are just Oracle? Well, you will call DISM this process into real-time class. So this opens up interesting security considerations, because if Oracle can put processes into real-time class, well, if you have 16 CPUs, start 16 real-time processes, right? Which perhaps don't release, the CPU pack at all. So, there are some interesting questions here. But anyways, I just wanted to start from explaining that this particular process is a phony background process, and it's needed for gaining root access for some operations like hiking the priority or allocating locked memory for SGA. The first useless bit of information, right? So you're not going to go and tune anything based on this information. However, if you tar up your Oracle home on this Solaris box and untar it here, and suddenly intimate shared memory is not allocated, or suddenly the high priority processes don't work anymore, they are on the regular priority, well, this is what you know. You got to see whether the DISM process still has the set UID bit. Okay, any questions so far? All right, so useless bit of information number 2. I'm going to start with this. So it's again 10G. Yeah, if you tar with minus P flag, it keeps the permissions and also if it can also the set UID bits, I guess. But then you have to untar it as root, right? Because if you untar it as Oracle, Oracle cannot somehow say that, hey, I'm going to put the root bit there as well. Yeah. So exactly, if you know this, if you know this stuff, you know how to avoid trouble and how to check whether you have issues. All right. So let's use a tracing tool. Just like when you want to trace what your application is doing, you can enable SQL trace, right? And it shows you what calls is your application making to the database. And equally, we can go a layer lower and trace Oracle itself and see what kind of calls is Oracle making to the layer below it, the OS. So I'm talking about system calls, right? Just want to show you how something works. So Riyaj Shamsuddin yesterday showed had a whole presentation about these tools. On Solaris, it's called Truss. On Linux, it's called strace, system call trace, right? And I picked the process ID 5721. So now I just attached to that process, this process who is my server process for this SQL Blast session. By the way, I will explain how I do get these numbers here in the end, so remind me. Anyway, so now when I run something, let's run select count star from DBA objects A, DBA objects B, right? There is no join condition. That should run for a while. All right. So you see a bunch of physical read system calls have been made. mmap is memory allocation nowadays for PGA. Okay. And now it seems to be stuck, but it's actually running. But now everything is cached, right? And it doesn't need to do any more system calls to read stuff from disk, right? And well, so it actually gets a bit more complex. But let me just scroll a bit up. Okay, so yeah, so I wanted to, gets a bit more complex because on Solaris there is one system call which Truss doesn't show if it's a lightweight system call. But anyway, you see there are system calls like times, for example. This is how Oracle asks from OS how much CPU I have used and how much of it was kernel mode and how much was user mode and so on. There is another system call which we don't see here because of this little issue. I can do it on Linux. I will run strace on Linux and 23821. Okay, so I attach to this process, and if I run something, you see there are a bunch of get time of day system calls. So this is what Truss on Solaris didn't show because it's the special case ultra fast system call there. But get time of day returns what is the current timestamp, right? And you see it actually returns the number of seconds since the Unix epoch from, epoch, or whatever, however you pronounce that, right? 1st of January 80 or 70, well, whatever, so it's 10 years only, different. and see, so basically this system call has returned that at the time when I run this, the time is this, this many seconds, this many microseconds, right? And Oracle is full of these calls because whenever you run SQL trace or whenever Oracle, calculates how long an IO wait took, it actually takes this time just before it issues the system call and just after when the system call finishes, right? So this is how Oracle knows the current time. I mean, for wait interface and everything. So if you trace an Oracle process, you see a lot of this. I can actually run, you see, like a summary. I'd say -CP that don't display individual system calls, but show me a summary in the end. And I run this thing once more. And I hit Control-C. And now you see counts, right? This little query cost 36 calls to get time of day, right? Some read operations, writes, and so on, which may be from disk or maybe from the sockets, that are used for communication. But anyway, so this is how Oracle knows high precision time. Okay. However, sometimes you have very tight loops. You have a nested loop operation, which never goes to disk because everything is cached, happens to be cached, right? And now you open up blocks from here and there, do logical reads, and you may do thousands and tens of thousands of logical reads per second, and you burn CPU a lot, right? And every now and then, Oracle needs to know what is the current time, because maybe maybe it needs to update SQL monitoring data, right? It doesn't always happen. It only happens when a timeout happens. Maybe it needs to update the $V session long ops data. Again, when you do this very tight loop of 10,000 of logical IOs per second, we are not going to update something 10,000. We are not going to update the metrics 10,000 times per second. It's just too inefficient. So now if you were an inexperienced developer, you would run this system call every time when you loop. But system calls are expensive. You issue the entire system call, you switch to kernel mode and so on, and you get the timestamp from somewhere and you kind of send it back. So that would be very slow. System calls are expensive CPU-wise, right? So that's why. So Oracle guys realized, okay, we want to be responsive. We want to know when when some amount of time has expired, but we don't want to run a system call 10,000 times per second. So therefore, Oracle guys have come up with a thing called SGA time, long time ago. And I'll show you how it affects some things. So there is SGA time, which is a variable in SGA, right? And Oracle goes, when it has this very tight loop, then instead of running the system call 10,000 times per second, it will just go and check this SGA variable, which tells us what is the current time, how a number of seconds since something, right? So it's much more efficient. But somebody has to maintain it. Somebody actually has to do the system calls maybe once per second and update this SGA time, right? So and in 10G it's log writer. Okay. So in 10G it's the log writer, and I'm going to show you how it affects things. All right. So this count finished. Let's do. Let's see. How do we do things here? Let me trust this process again. This is the Solaris 10G, right? And let's sleep for whatever, 300 seconds. Okay, you see, this command was parsed, and whatever happened here, we had a bunch of activity, and now this is the system call how on Solaris we go to sleep voluntarily. It's set timed operation. It's basically, wait for 300 seconds. So my process is off the CPU. It's not coming back onto the CPU before 300 seconds has expired. All right? And now, in another window, let's say I'm the DBA, I am investigating why did this session get stuck. So my session ID is 144. Before I scroll back, you see my SW script is the session wait, right? It queries $V session wait, and it shows for how long this session has been waiting. Okay. Okay, I think I picked that's actually weird. Demo effect, as I said, I haven't prepared for this. So the seconds in waiting should go up, but maybe I'm doing something wrong. Instead of troubleshooting this at the moment, I will use a different wait. Instead of this, I will just do. I'll put it through. Okay, now this guy is stuck. Let's see what is this guy doing. So 148. So okay. So so anyway, so let's use this. Let's take a little detour here. So whenever you wait for a reliable message, as I said, remember. So this is a completely useless hacking session. Don't expect to get anything useful out of it. So I think I know what's going on. I played around with freezing the instance. So I think the instance is frozen, but let's see. So I'm waiting for a reliable message. What is a reliable message? Reliable message is, let's say, a command what I send to a background process, for example. And my wait, when I send it out, I'm going to start waiting for the reliable message. And my wait doesn't end until the background process acknowledges it, that, yep, I got it. Because if you look into Unix, I can post a semaphore. I can post the semaphore of the other process. But unfortunately, in the older times, back in the past, it wasn't guaranteed that the post actually arrives, right? Which, let me take a detour of that detour now. So that's somewhat related. So there is in some version there is a parameter called enable reliable waits, which shows up, which tells us that posts, when I send a message wake up call to a process, it's guaranteed that it will wake up. But anyway, so forget about this part. Anyway, our session is stuck on reliable message. All right, and reliable message requires the target to acknowledge, right? So apparently, either the target did not get the message at all, or the target hasn't replied with an acknowledgement, right? Okay, so and the wait interface helpfully tells us extra information that in which channel or through which channel did we send the message. So I can say I have a little script which queries a bunch of $X called channels, which lists what channels do we have in the system. So if I search for this context, let's highlight this. So reliable message. We have 2 channels here. Okay. I just want to show where it's. Yeah, I think that it's the best to start from this. So I think I'm waiting for a channel on this address, right? And then I search. Okay, what channels do we have which actually use this address? And there is a thing called object broadcast channel. Whenever you drop or truncate the table, Oracle will have to flush any dirty blocks of that segment to disk. And for that, it actually sends a reliable message to checkpoint process, who will then take an enqueue, KO or RO. There are this RO or KO enqueues, and then checkpoint sends a message back that, yep, acknowledged, right? But it holds the enqueue. And your process now tries to get the same enqueue, and it will wait until checkpoint is done checkpointing, and it will release the enqueue then. So basically, that's a synchronization mechanism. And apparently, checkpoint process has not. So basically, that's the object broadcast channel, and we have multiple lines here. We kind of have the owner of the channel who listens, and we have also the ones who have subscribed to it or who are using it. So it's an object broadcast channel. And this is the checkpoint process. And you see, so the checkpoint process, as you see from here, it's the subscriber. Checkpoint process is the one who waits on the channel that somebody would send it messages. Do checkpoint this and that. All right. But anyway, where we want to go really is that from here we kind of see that it's the checkpoint process who is subscriber, who is servicing us via that channel. Let's see what checkpoint itself does. So 165. The seed of checkpoint is 165. So checkpoint itself, okay, it gets more interesting. You see, there are wait events, RDBMS IPC message. This really means that I'm idle, right, as the wait class says. So it really looks like the checkpoint has not received this message at all. Because otherwise checkpoint would be doing something. If I was waiting for RDBMS IPC reply, then it would mean that I'm waiting for a reply from some other process. And in this case, the parameter 1 would show us the Oracle PID of that process. All right. But anyway, so it even hasn't gotten it's idle. It hasn't even gotten the command. So this is really weird. And it may have something to do with the fact that I had truss running here. Because when you have truss running on, when you run truss on a process, you're kind of attaching a debugger to it, which means that when a signal is sent to your process, the debugger can say that ignore any incoming signals, don't disturb me. So I suspect that if I Control C now, either the thing continues or crashes. So it's a hell of a detour, but Okay, where is my? Okay, let's say 148. Still reliable message. I think I messed it up with the debugger, with the trash. So let's do this now. Let's invoke checkpoint otherwise, because checkpoint hasn't woken up, but this message has been put into this message area. So if you wake up checkpoint otherwise, let's see whether it picks up that message. It it probably doesn't even know that there is a message waiting for it. So if we do alter system checkpoint, I'm really hoping that it will continue. But okay, now this guy is stuck as well. So, I played around with Aura debug earlier, and that's why you should not do it, or do it only at home. So there's a thing called flash freeze, which will freeze the instance. So so that if you want to take some sort of from it and so on. So let's see if I can status, yeah. So Aura debug. Okay, now it's in some trace file, I suspect. So this ended up as a troubleshooting session of, not, yeah, not surprised. Okay, so 5783. Okay, actually nothing was dumped here. So instead I will just, sorry? But I will just do ff resume. Ff resume instance. Or debug. Let's see if that. Okay, yeah, I was stupid myself. So I tried to play around with a thing called, there was Kyle mentioned cows here, copy on right, cow. But there are actually cows in Oracle SGA as well. So I just wanted to show that. So when you it's actually possible to freeze your instance and dump the entire SGA to disk. So you could later on, when the hang happens or whatever, you dump it to disk, and later on you attach to that dump and treat it as SGA and run hang analyze and whatever commands on it. But anyway, let's ignore that. So anyway, now everything continued, and now I have to recall what the hell I was going to demo here. So all the scripts that I've shown, these are all in my blog. I will show that as well. So, okay. So I was talking about SGA time, right? So I dropped the table because I just wanted to get rid of it, so it wasn't part of the demo. So SGA time. So it's the log writer who does this, and now I know why this. Now I know why this time didn't increment. So this is where I started. So I'm stuck. I'm sleeping. I voluntarily go to sleep, and now in the other session, let's look into the session wait. And you see, seconds in wait is 9 seconds. And let me just run it a few times in a row. You see 18, 21, 24. You see it's like, this number is updated every 3 seconds, right? And now you have internet full of log entries which say that this number is updated every 3 seconds, all right? So, but what if we actually run some activity? Let's just do a drop table. Okay, I already dropped the table T, but create table T. Exec while true loop insert into T values 1. Sleep half a second perhaps, commit and loop. All right, so there is a catch here with the comments as well, but anyway, so now we are actually doing something every half a second. And let's see whether this number now increments faster. So this is a completely different session, right? Okay, 84, 85, 86, 87, 88. So now it's updated every second. kill this guy. 96, 99, 102. So now it's updated every 3 seconds again. Well, could it be log writer? Well, it's easy. There is a pretty long gap in between, but basically, years ago I figured out that it's the log writer in 10G. It's actually log writer who updates the thing called SGA time, and this number comes from when the wait started minus SGA time, or whatever way it is, right? So if SGA time is not updated, then this number, this seconds in wait, doesn't go up. Because Oracle doesn't want to run a system call every time it loops somewhere, just to see whether, what the times are, right? So it relies on the SGA time. So let me just do something then. Well, actually, we should use big rep nowadays, so it saves a few characters of typing. All right. LF. All right. So this is log writer. Okay, 168 seconds, 171, 174. Let's kill minus stop log writer. This doesn't kill it, it suspends it, right? You don't want to kill your log writer, right? So the demo would be over. So, but yeah, this is production. It's a customer system, yeah. So, yeah. But they're not running too important things. So it's only a couple of million dollars per hour, right? So anyway, you see, seconds in wait is stuck. So the time has stopped in Oracle, right? So let me just release the log writer again, kill minus continue, and now suddenly it jumps to whatever the time is. Okay, so this is because the session wait, these numbers in session wait come from the timestamp. We subtract, or is it subtract? Subtract. Basically, we take the we take whatever is the current SGA time, and we take subtract the wait start time from there. It's 1.3 billion 10 seconds, and it's 1.3 billion seconds when the wait started. Therefore, we have waited for 10 seconds. And the current SGA time is maintained by log writer in Oracle 10 up to 10. In 11, it's VKTM, right? It's the VKTM process who does that. And if VKTM has a higher priority, it does this every 20 milliseconds or something like that. Actually, there is another parameter which has millisecond granularity. But so where would it be useful to know this stuff? I have this little note here some things actually depend on this SGA time. So if you set timed OS statistics to 5 seconds, well, it's the SGA time which is used. Again, for finding whether we should take another sample of OS statistics for that process, right? Session long ops, they kick in. You can see a blog entry that they kick in 6 seconds after the full label scan or whatever started, but actually it kicks in 5 seconds. But if you test it on in your laptop, where log writer wakes up every 3 seconds, right? Then you're not going to see that the timeout has expired before 6 seconds has expired. You sleep for 3 seconds and you sleep for 3 seconds again. What else? So seconds in wait is based on that. The rolling invalidation of cursors when you use the no invalidate equals auto invalidate, right? So that's dependent on the SGA time comparison as well. I think this SQL bind capture is dependent on that as well. Just something interesting. So in Oracle, there is a thing called KTU. Nope. I have. Okay. So whenever I remember the, sometimes I don't remember the parameter name, but I remember the default value is. So I can search for, show me any parameter where the default value is 5. So let's see. Yeah, I don't remember what this parameter is. There is a parameter called enable timeout actions or something like that, which controls this logic a bit. So things like SQL monitoring and so on, again, they don't kick in before the SGA time-based timeout kicks in. Okay, so and I mean, you don't really need to, I mean, this is again one of these useless things what I mentioned, you don't go and tune a system based on that, but it can help you to explain some things a bit better. And when log writer gets stuck, hung for some reason, then, a lot of other things become really weird as well. And so I was talking about $v session wait. So let's see if we can, I'm gonna just show some of the research techniques I use. If I want to see where do these values come from, right, I can use a script called v, which just shows me the, the text of the $v views, right? It uses $v fixed view definition for that. You cannot get this text from DBA views. It's some endless loop there, but from here you can get it. So $v session wait, and and we wanted seconds in wait, which is the second last column. So this is so this is a decode statement. All right, KSUC wait time. So basically, you see, apparently we will take it. This is an $x table, and we take from this $x table. So if I just do a describe, you see it's the last column, right? But if I do an $x describe, which describes $x a bit better, again, it's a script which you can download. It shows me a bit more information, including what is the offset of this record. Okay, and here we have an issue. It doesn't actually show that. So in an earlier version, I actually tested this, and I found the offset was listed here. So I could actually use Aura debug to peek into this memory, and indeed, it showed the wait start time there. But when you query this $x, then Oracle always took the SGA time and subtracted the wait start, and this is how it got the wait time. But anyway, so that's a bit too much details. But in 11G, when you do the same trick with VKTM, you suspend VKTM again, some processes kind of stop in Oracle. All right, so I have like 12 minutes left, right? So do you have any questions so far? I have no clue what half of them are doing. I don't remember anymore. Nope. And sometimes this is maybe a good example of my consistency. I'm thinking that, hey, I should put this into a script, and I will write it, and I will save it. And I think, okay, this script should be called XYZ2. And I see that this file already exists because I've already created the script like 2 years ago and named it exactly the same. That's, my brain still works the same way. But if you go to the scripts directory, this is where you have all of it. And by the way, well, let me just finish with this. I mean, if you're too lazy and you don't care about what might happen in your databases, you can even run stuff like this, right? So you just take demos xterm color, right? You can run stuff from FTP locations as well. If someday I'm drunk and I go back and put the shutdown abort in the beginning, it's your fault, if you crash something. Okay, so I think we are done. So thank you very much. So who's next?